Hello everyone, welcome back to the Java tutorial series. In this video, we are going to learn the basics of exceptions in Java. And by the end of this video, you will understand what exceptions are, why they occur, and the different type of exceptions, and why exception handling is important. And we will get some basic introduction to handling exceptions using try and catch. So let's get started. So what is an exception? So an exception is a unexpected event. Okay. So an exception is an unexpected event. That means unexpected means we were not thinking this will happen, but it happened in the code. Okay. It might be some error, some exception. Okay. So while program is running, we can get an exception. Okay. That means it interrupts the normal flow of execution. So we assume like, okay, this code will run and this statement will execute after this statement, like that. So the normal flow, it will not execute, it will interrupt the normal flow and it will give some exception. So it occurs during program execution. So whenever we execute the program, some unexpected event can happen. Okay. So disrupts normal flow of the program. So this is an exception. Okay. So let's take an example so we'll understand better. So think of exception like in real life problems. Okay. For example, let's say if you are dividing a number by 0, any number you can take. Okay. So you are dividing a number, let's say 11 by 0. So what will be the output? So it will cause an exception, right? And similarly, we can have it as per mathematical calculation, we will get infinite. Okay. But since this will give in the code some exception. Likewise, accessing invalid array index. Okay. So let's say we have index up to 10 or 10 and we are trying to access some index which is of 20. Then it will throw some exception in this case also. So accessing invalid array index. Invalid means more than size. It can be more than size. Okay. So let's say we have 10 and if we are trying to access in the array index of 20, then it will throw exception. And file not found exception. That means we are trying to get file, we are trying to fetch the file details, but file does not exist. Then it will throw this exception. So these are like examples. So there are many exceptions which can be occur during the execution of the program. Okay, so this will cause error during exception. So let's go to IntelliJ and see some exception so that we can have the better clarity. Okay, let's go. So what we are learning today, exception. Okay, so I will define some variables here. Int a equals to 10 and let's say b equals to 0. Now what I am doing, I am just using an arithmetic expression, that is division, and I am taking the output in the variable called result. And what I am doing is I will print the whatever result we are getting. Okay. So in this case, the value of a is 10 and value of b is 0. So we are dividing 10 by 0. Okay. So this is not valid scenario, right? So the execution will not be in the normal flow. This program will throw the exception. Why? Because we are trying some invalid scenario. Let's run and verify it. So here you can see the exception. Exception in thread main. So dividing by 0, see here, dividing by 0 will cause an exception, and we call this exception as arithmetic exception. You can see here it is written arithmetic exception. So every exception is categorized. Okay, so based on that it will throw an exception. So since it is related to arithmetic operation, so it is throwing an arithmetic exception, and it is mentioning reason divide by 0. So this is one of the simplest example of the getting exception. Okay, now what happens without handling? So in this last example we have not provided anything, right? We were just seeing what is happening. So what it is written here, so whenever we get some exception, what will happen at that particular line, program will terminate abnormally. So in the line we have written a divided by b into result. So a is 10 and b is 0. So in this line only we will get an exception called arithmetic exception. So what will happen? Whatever lines of code we have written after this line will not get executed. In the same line only, in this line only we will get the exception, and exception will print in the console, and program will terminate abnormally. Okay, and remaining code will not execute. So whatever lines of code we have written after this statement, those lines will not get executed. Okay, so if exceptions are not handled, see we have not handled, okay, we have not provided any handling of this exception. We have just written the normal code flow. We have not handling. So if we don't handle the exception, then what will happen? Program will terminate immediately, and the remaining lines of code will not get execute. Okay, so we understood what is exception and what will happen if we don't handle the exception. Now let's understand the inheritance hierarchy of exception handling class. So we have the parent, okay, this one, throwable is what? Parent class. This is parent class. What we are learning? Inheritance hierarchy. We know, right? Inheritance means parent and class relationship. So we are looking inheritance hierarchy for what? Exception handling classes. Okay. So throwable is the parent class. So how it is defined? This is package name, right? Java.lang is package name, and this is class name, and this is what? Package name. So if you observe all the classes we have mentioned, it belongs to java.lang package, java.lang package. Okay, and these are what classes name. Throwable is the class, error is the class, exception is the class name, runtime exception is the class name. Okay, so now if we see, throwable is the what? Parent class. Okay, parent class, and these are what? Error and exception are the child classes. These are what? Child classes. Now throwable is the parent class and exception is the child class, and error is also child class of throwable class. So we can get error, okay, fatal or unrecoverable error. In which case, example is stack overflow error, out of memory error. So with this kind of exception error, we will get the error. Okay, this is error, not exception. And for exception, we have another bifurcation, that is runtime exception or checked exception. So you can think of like this is the exception class, and exception is further divided into checked exception and unchecked exception. So this category is unchecked exception category, and this category is checked exception category. Okay, now you must be thinking, what is this checked and unchecked? So simply, unchecked means whatever classes, whatever exception classes that are inherited from runtime exception class. Okay, runtime exception is what? Runtime exception is a child class of parent exception. Okay, and an exception is a child class of parent throwable. So are you getting hierarchy? Throwable is a parent class, exception is child class. Now exception is parent class for the runtime exception and checked exception. Okay, so runtime exception, so whatever exception class, okay, we can have different exception classes. So whatever exception class whose parent are runtime exception class, or in other words, you can say the classes, the child classes that are inherited from runtime exception class, those exception classes, those child exception classes belong to unchecked exception category. I repeat. So we will be having different exception classes, right? So these exception classes, just now in the last example we have seen arithmetic exception. So this is what one class, right? So this is child class which is inherited from runtime exception class. Okay, so since exception, arithmetic exception is inherited from runtime exception, we will call arithmetic exception as unchecked exception category. Okay, and similarly, all those classes, exception classes, which are not inherited by runtime exception are called checked exception category. As simple as that. So how we are dividing this unchecked and checked based on the class runtime exception. Runtime exception. So whichever class which are inherited by runtime exception, what we are calling unchecked exception category. And those classes which are not inherited from the runtime exception are called checked exception category. And these are the examples for checked exception: IO exception, parse exception, file not found exception. Okay, by name it is clear. IO means some input output operation we are performing and we are getting exception on that. Parsing, okay, we'll understand. File not found, okay, file is not available, then we'll get this exception. Class not found, socket exception, interrupted exception. Okay, don't worry about this, just try to understand. These are checked exception. Okay, for now understand what is checked and unchecked. So these are the examples of checked and unchecked exception. So parent class is throwable and the child class is exception, and further exception is the parent class for the child class runtime exception. So this is the hierarchy. Okay, and from runtime exception, so whatever class that are inherited from runtime exception, those are unchecked exception category, and those classes which are not inherited from runtime exception are called checked exception category. Okay, so this is like hierarchy of exception handling classes. So these are the classes which are used in the exception handling. Okay, these are the main classes, and whatever individual exception class, those will belong to either it will be unchecked or checked exception. Okay, so in Java, all exceptions are part of this hierarchy. Okay, the base class of parent class is throwable, and which has two main subclasses. One is the exception and another is the error. Okay, and exception is again bifurcated into runtime exception. This is not any class for checked exception. So whichever class are not inherited from runtime, we call it as checked exception. Okay, now let's move. So we have seen the types of exception, that is checked exception and unchecked exception. Okay, these are the main two types of exception. Okay, and okay, we'll see one by one what it is. So we'll start with the checked exception. Okay, so checked exception. So checked exception are checked during compile time, and it must be handled, okay, either using try catch or declared using throws block. So implementation wise, we will understand with the examples. So what we know checked exception means, exception classes. So we have list of exception classes which are checked exception. Okay, so exception classes which are not inherited from runtime exception class. Okay, so those classes are called checked exception, and these classes will be checked during compile time, and this kind of exception must be handled. What do we mean by handled? Handled means we will use try catch block. Okay, we will see how it works, but as of now just try to understand checked exception must be handled. Okay, how means we have to approach this try your catch block or using throws keyword. Okay, we will see this part later, but just remember that we need to handle the checked exception, and these are the example: IO exception, input output exception, or SQL exception. This is related to database. We will have a different playlist for SQL and database exception. SQL is the database exception, maybe connectivity issue or something related to DB. Okay, now let's see the unchecked exception. So unchecked exception means classes, exception classes which are inherited from runtime exception class. So runtime exception class will be like parent class, and whatever exception class, that is child class. So those child class will be unchecked exceptions, will be part of unchecked exception. Okay, so whichever class which are inherited from runtime exception are called unchecked exception. So there are some rules for unchecked exception. It occurs at runtime. Okay, so not mandatory to handle. So compiler will not force to handle during compile time. Okay, it is not mandatory, like arithmetic exception, null pointer exception. So compiler will not force. Compiler always forces to provide or handle the exception for the checked exception. This is an important point. And for unchecked exception, it is not mandatory to handle. So compiler will force to handle the exception for only checked exception. Okay. So this is like exception handling flow. Okay. How the flow will happen, how we are writing the code, and how these exceptions are occurring, and how we are handling those exceptions. Okay, we will understand here. So this is complete flow of exception handling. So complete flow of exception handling. So let's say we have seen one example, right? Divided by 0. So let's say we are getting this arithmetic exception. We are using 10 divided by 0. So this will what give arithmetic exception. Okay. So divide by 0. How this process will occur? So first step is it will check which type of error it is. Okay. So it is type of exception. We have seen in the hierarchy, right? Throwable will be there. Throwable is what? Parent class. Throwable. Out of which error, again child class and exception. So it will bifurcate in which category it belongs. And it will say, yeah, it belongs to exception class. Now, exception also we have a different kind of exception, right? So it will create a matching instance of the matching exception class. So whichever exception class, let's say arithmetic exception. So what it will do, it will create an instance of arithmetic exception. Okay, it will create an arithmetic exception instance. Instance means an object. Okay, how it will object? See here, new arithmetic exception and the parameter. So it will create an object of the matching exception class. And the third step is throwing. Okay, it will throw this exception. Okay, so whenever we will run the program, and if it execute this line divide by 0, so first step it will check whether it is a error or an exception based on the exception class hierarchy, and it will find out the exception class. Okay, now he got the exception class. So after getting exception class, matching exception class, it will create an object. Okay, new arithmetic exception. And the third step, it will throw. Throw means program will stop immediately, and this exception will occur in the console, and program will terminate in this line itself. Okay, so how it will happen? After throwing this exception, it will check whether in the code we have provided the handling or not. If we have provided exception handling, let's say try and catch block, then it will abort try block and executes catch block, and code continues. Okay, let's say I will give you an example. Let's say we have try. So we have two blocks. Okay, one is try and another is catch. So whatever lines of code we want to execute, we will write inside try block. And if any exception occur in these lines of code, so during that statement, from that statement, execution will go to the catch block. And catch block, inside catch block, it will execute the lines of code. And after catch block, whatever number of lines of code that will execute. So this is the execution flow. So we will have the main logic inside try block and failing logic inside catch block. Failing logic means what will happen if exception occur. So those part we will write inside catch block. So let's say we are getting arithmetic exception. So code is written inside try block. So from that line, it will go to the catch block, and inside catch block, the failing logic will be there. In the failing logic, we can write which exception class, what error we are getting, those things. Those details we can write here inside catch block. And after catch block, whatever lines of code is written, those lines will get executed. So there is no program termination immediately. There is a flow of execution. If we are providing try and catch block. So catch is used to catch the exception class, okay, and execute lines of code if exception occurs. And after ending of the catch block, remaining lines of code will get execute. Okay, and let's say after finding the matching exception class, Java tried to find out the matching handler, and suppose it did not find the try and catch block, then or any handler. So we are not handling. Programmer has not provided any handling of exception. In that case, JVM will abort code immediately and print the whatever exception class details and the stack trace. So whatever error details, exception details, what is the exception class, what is the reason, those details it will print, but program will be terminated immediately. So this is the advantage of providing the handler. Handler means try and catch block. So now you understood the difference, right? So if we are providing the handler means the code written in the inside try block, if any exception occur, it will go to catch block and it will write the exception details. And after that, if any code is written, those will get executed. So there is a proper sequence of execution. But whereas if you are not providing any try catch block, normally code is getting executed. So in the exception code, exception statement, program will terminate and remaining lines of code will not get executed. So this is the difference between providing handler and without handler. Okay, so this is whole execution exception handling flow from getting exception to the handling exception. And if you are not handling, program will terminate and remaining lines of code will not get executed. Okay. Now, why exception handling? We have seen just now. If you are not providing any exception handling, what will happen? What will happen? Program will terminate itself. But if we are providing handling, okay, if we are handling the exception, what will happen? It will prevent from program crash. Program will not terminate immediately. It will maintain normal flow. So let's say we have provided one try block. Okay, we have written lines of code. So if any exception occur in between, then it will go to the catch block and it will print the exception details, error details, and remaining lines of code will get executed. So there is a flow, right? If exception occur, it will go to these lines of code, and after completing these lines of code, it will go to this lines of code. So there is a proper flow. Okay, so it will maintain normal flow if we are handling exception and handle errors gracefully. Okay, so this is the advantage of using exception handling. So exception handling helps to prevent programs from crashing. Okay, and it allows us to handle errors gracefully and maintain the normal flow of the application. Okay, now let's see some basic exception handling keywords. How do we handle? What are the keywords used in Java to handle the exception? Okay, so Java provides several keywords for exception handling. Okay, those are try, catch, finally, throw. So these are the keywords which we will be using to handle the exception. Okay, so we will learn each of these in detail in the upcoming video. Okay, but for now, try to catch these keywords. Okay, try, catch, finally, throw, throws. We'll understand the difference in detail. Don't worry. Okay. So let me show you simple try catch block, what it is and how do we use. Okay. So this time I am handling exception. Okay, how do we handle the exception? Using try catch block. So there is a try block. Okay, and inside try block what we will write? Okay, here I will provide catch. Okay, so and here I will provide exception here. So this is what try catch block. So inside try block what we will write? Inside try block we will write the code which we want to execute. Okay, so what will be inside? Let's say int a equals to 10 divided by 0. Okay, so I have written one line, int a equal to 10 by 0. Okay, and we know, right, 10 by 0 will throw some exception. What will be that exception? Arithmetic exception. So since we are getting exception inside try block, okay, since we are getting exception inside try block, so that particular exception will be going into catch block, and after getting exception it will execute the catch block and it will execute the catch block whatever we have written. So let's say I will write cannot divide by 0. So I want, if exception occur, it should print cannot divide by 0. So inside catch block what we write? After getting exception, what we want to do. So those lines of code will be written inside catch block. Okay, so this is, you can consider as the exception block. If exception occur, what we want to do, and this is the normal code which we write. Okay, so here the code that may throw an exception, okay, here the code that may throw an exception will provide inside the try block, and when this exception will occur, okay, the catch block will handle that exception and preventing the program from crashing or terminating in the exception line. So in this line we will get arithmetic exception. Okay, if we don't provide try and catch block, what will happen? Program will terminate in this line itself, line number 15, program will terminate. But since we have provided try catch block, what will happen? Execution flow will go from line number 15 to line number 17 and catch block will handle the exception. So it will execute line number 18 and 19. Okay, and even then, if you have written something here, let's say except outside or remaining lines of code, I will write some meaningful remaining lines of code. So this will get executed. Okay, let me verify it. See, so exception occur here, then it went inside catch block, it printed cannot divide by 0, see in the output, and after that it printed remaining lines of code. So this is the power of try and catch block. Even if we are getting exception, these are handled gracefully. Okay, so we will understand in detail try and catch block. I hope you understood how it is working for now. So let's quickly summarize what we have learned so far. So an exception is an unexpected event, okay, that will disrupt the normal flow of program. Okay, that will disrupt the program flow. Okay, exception is a runtime error, and Java provides exception handling mechanism using try catch block to manage these situations. And we also learned that exceptions are broadly classified into two types. What are those? Checked and unchecked exception. So exception which are inherited from runtime exception, we call it as unchecked, and exception classes which are not inherited from runtime exception class, those are checked exception, and compiler forces to handle checked exception during compile time. So we need to handle checked exception using try catch block. Okay, so that's all for this video. I hope this tutorial helped you understand the concept of exception in Java. Thanks for watching, and I will see you in the next video.